So next one is going to be a T-type matching network. So as you can see, T and pi are complementary. So in pi, I had two shunt and one series. In T, I'm going to have two series and one shunt. And that one shunt, I'm splitting it again into two parallel. So it again resembles like your two L-type network. So T is also going to be two L-type sections. So if you connect the L-type sections in the reverse way, it is going to be T. If you connect it back to back, it is going to be pi. Here, what would be a single capacitor in practical implementation? Actually, you have two capacitors in parallel. Circuit-wise, you'll have one capacitance. If that capacitance is not possible to fabricate a single capacitance, you can have two capacitors in parallel. That's also possible. So here also we have the image resistor at midpoint of the T matching network. The image will come somewhere in the middle. So same way here also we can say that the image resistance will be a point of concern which is going to transform the input resistance to your load resistance RL. T is you have two series elements in T, right? So T is particularly used when the parasitics are primarily inductive, whereas pi is used and the parasitics are going to be completely capacitive. So we are going to handle two types of scenarios also. So given a circuit, if you are going to find that the parasitic elements are going to be inductively dominant, I go for T. If it is capacitively dominant, I am going to go for pi type matching network.